Okay, so today we're going to talk about arithmetic sequences. The first thing you got here is a couple of definitions that you need to know. A sequence is just an ordered list of numbers. It's any set of numbers that are in any specific order. A term is what you call each of the numbers. Each of the numbers is a term. The 1, the 3, the 5, the 7, those are all terms. And an arithmetic sequence is when the terms all have the same difference. Okay? Which means there's all the same distance between each number. Okay, like the 1 and the 3, that's a distance of 2. The 3 and the 5, it's a distance of 2. The 5 and the 7, also a distance of 2. Then we have a common difference. The common difference is whatever that distance is, as long as it's all the same. So if they all have a difference of 2, then the common difference is 2. So as you can see, the sequence is, that whole thing is a sequence because it's an order of numbers. The term, the 1's a term. I could have also circled the 3, 5, and 7. And that sequence is arithmetic because they all have the same distance between them. And then that common difference is 2 because it goes up 2 every time. Okay, so this is the bell ringer. We've got this sequence, and we're asked to find the next 3 terms. Well, now we know what terms are. We know that the next 3 terms are the next 3 numbers. So hopefully we could all find that the next 3 in this sequence were 9, 11, and then 13 if we just follow the same pattern. Okay, but now we're asked to find the 100th term. Well, that could be kind of tricky because it would take a while just to keep adding 2 every time, do it 100 times, and see what I ended up with. And even if you did that, you might count wrong and end up with the 99th term instead of the 100th. So that's not really the best method. What we're going to do is write an equation. Okay, so the first thing I'm going to find is the common difference. There's only 2 numbers I need. The first is the common difference. Well, the common difference here is 2 because it goes up 2 every time. The other thing I need is the starting point, which means where did this come from? Starting from the first one, what would be right in front of the first one? That would be where it came from. So if you had to back up, in essence, what number would have come in this sequence before the 1? Well, it would be a negative 1. Because if it's going up 2 every time, then you'd have to start it at negative 1 to go up 2 and get to a 1. So now, these 2 numbers are the only numbers we need. We can write our equation. Okay, the equation always looks like this. Okay, I don't want to take that. Always looks like this. Y equals some number times x, and then either a number added or subtracted. Well, the common difference is always that number you put in front of the x. And the starting point is always whatever's added or subtracted. That's why they're the same color. So it's y equals 2x because the common difference is 2, minus 1 because the starting point was negative 1. Now, that gives us our equation, but we still don't have the 100th term. How do we do that? Well, here's where we take the 100 and we put it in where the x is. And now that gives me y equals 2 times 100 minus 1. So I know that 2 times 100 minus 1 is 199. Therefore, the 100th term is 199. Okay, now there are 3 things you have to be able to do for today's lesson. This is the first. You have to be able to look at a sequence and identify whether or not that sequence is an arithmetic sequence or not. Okay, very simple to tell. All you have to do is look and see, is there a common difference? Okay, if there's a common difference, it's arithmetic. If there's not a common difference, it's not arithmetic. It's that simple. So here's a couple of sequences I want you to try to look at and see if you can tell whether they're arithmetic or not. Okay, so looking at the first one, I can see that they increase by 3 every time. So that one is arithmetic because it goes up the same amount every time. Looking at the second one, I can see it goes up by 2, but then it goes up by 4. So that's not the same. So there's no common difference. So that one is not arithmetic. Looking at the third one, I can see it increases by 90, and then the next time it increases by 900. So that's definitely not arithmetic. And looking at the last one, it increases by 5, then it increases by 5 again. So the last one is arithmetic. Okay, now here's what the problems would look like. So I'm going to give you 2, and you're going to work them out, and then we'll check them. Okay, the question would look like this. Is this arithmetic? If so, state the common difference. Okay, or it'd say, is this sequence arithmetic? If so, state the common difference. Okay, so here's one sequence, and here's another. Okay, now the first one, it's going down. Well, that means it's increasing by a negative number. So from 20 to 14 is minus 6. So I check the next one, and 14 to 8 is also minus 6. So since they're the same, it does have a common difference. So it is arithmetic, and the common difference is negative 6. Now looking at the second one. The second one is going from negative 4 to negative 1. Well, that's plus 3, because you'd have to add 3 to negative 4 to get to negative 1. And then from negative 1 to 2, I would also have to add 3. So since there's a common difference, then yes, it is arithmetic, and that common difference is 3. Okay, the second thing you have to know how to do. You have to be able to write an equation for the sequence. Okay, so let's look at an example. Okay, here's 2 examples. I'm still doing the same thing. I'm going to find the common difference, and then I'm going to find the starting point. Remember we did that earlier? So I look back from that first number and see where did it come from. Okay, so I've said, okay, it's going up 7 every time. So if I went back from the 8, where would it have come from? What would have had to come from 1 so that when I add 7, I would get to 8? Again, these are the only 2 numbers we need. And then we say y equals 7x plus 1, because the common difference is 7 and the starting point was positive 1. Okay, now looking at the second one, same thing. from 10 to 7 is negative 3. From 7 to 4 is negative 3. So my common difference is negative 3. Then I look back from the first one to see where it started from, and I see it would have started at 13, so that it could go down 3 and get to 10. So my starting point is 13. That means my equation is y equals negative 3x plus 13. So here's some for you to try. Okay, this is what the question would look like. It would just say, write the equation for this sequence. So here's one sequence, and here's another. Okay, so go ahead and try these. Okay, you're always starting out by finding the common difference. In this case, it's negative 4. Then looking for the starting point. In this case, it would be 9. So then that gives me y equals negative 4x plus 9. That's the equation. So looking at the second one, it's going up 3, so plus 3. So the common difference is 3. Then when I look back from 1, it actually had to start at negative 2 so that it could go up 3 and get to the 1. So my starting point is negative 2. So my equation is y equals 3x minus 2. Okay, and the third and final thing you have to know how to do today is find any term in the sequence. Okay? In order to find any term, first you have to have the equation. The equation is the key to get to any term you need. So if you write the equation, then you can plug in whatever term you need. If you're looking for the 100th term, you can plug 100 in for the x. Okay, so the first thing is you still have to find the common difference and the starting point. So the common difference here is 5 because it goes up 5 every time. And if I find the starting point back from 3, it would have to go back to negative 2. So my equation is y equals 5x minus 2. So now I have to take that 100, since that's the term I want, and put it in for the x. So that gives me y equals 5 times 100 minus 2. And that equals 500 minus 2, which equals 498. So the 100th term of this sequence is 498. Okay, so now here's some for you to try. This time you're going to find the 50th term. Okay, so you need to find the 50th term of these two sequences. Always start with the common difference. Common difference is 2. Then look back for the starting point. It's also 2. So my equation is y equals 2x plus 2. And then since I'm looking for the 50th term, I put a 50 in for x. That gives me 100 plus 2. So the 50th term for this sequence is 102. The next one, common difference is 10. And if you look back for the starting point, if you look back from 10, the starting point is 0. So that makes my equation, y equals 10x plus 0, which I don't really have to write. Okay, so then I plug in, since I'm looking for the 50th term, I plug in the 50 for the x, and I get y equals 500. So the 50th term would be 500.